5-3. Finishing it up with this one problem. Make sure you have your calculators. We're going to need them. One method of determining how the x and the y values for a set of nonlinear data are related is to take the natural log of the x and the y values. So we're going to take the natural log of both x and y. Okay. If the points when graphed fall on a line, then you can determine that the x and y values are related by the equation natural log of y equals m natural log of x. M is the slope of the line. Okay, so there's the situation. Here's the problem. The table shows the mean distance from the sun, x, and the period, y, the time it takes the planet to orbit the sun, for each of the 6 planets that are closest to the sun. In the table, the mean distance is given in terms of astronomical units, where Earth mean distance is defined as 1, and the period is given in years. Find an equation that relates y and x. Do y'all understand what it's talking about, astronomical units there? Not necessarily, not. Yeah, they're saying, what they're saying is the distance from the Earth to the sun is 1. Okay. Mercury is about 38% of that. Does that make sense? So that means Mercury's closer, where Saturn is about 9.5 times further away from the sun than the Earth. So they're basically saying, you know, we're not measuring in inches, we're measuring in sun to Earth units. Okay. Years, we're talking about 1 year for Earth versus how long it takes the other planets to go around the sun. Okay, so here's our data. So let's start off and let's take a look at what that data looks like in our calculators. So put the mean distance values, those are your x's, put those into L1 and put the period into L2. Stat. Go to stat, and that's where you put your L1s and L2s, right? Okay, so stat, edit, L1. Do what? Yes, 1.881. Oh, you can't see it on your screens at all? Okay. Are you waiting to join or? Okay. Those tiny. Okay, so I do what? It's only the 6 planets closer to the sun. My very efficient mother just served, so it stops at Saturn. Okay. Are you trying to make me say, no, we're missing Uranus? No, I'm not going to go there. I'm not going to follow. I'm not going there. Okay. Exactly. See, why did you just conveniently skip that one? And you don't even think Pluto's a planet anymore. You're along in that camp, right? Poor Pluto. Okay. I want to look at this data and see, is this data, does it appear to be linear? How do I do that? Do y'all remember? Press graph and you'll see nothing. What, Kenny?
Oh, stop calc 1, right? Would that work?
I don't know what you're talking about. Okay. This is data. Data is also called statistics. This is going to be a scatter plot. So we're going to go to stat plot. Okay. So second, stat plot. By default, when you reset your calculators, all plots are turned off. Okay. I'm currently on number 1. I will press enter to get into the settings for stat plot 1. Okay. So the question was, how did I do that again? So here we go. Second, stat plot. Because stat plot is right there. Enter. Now notice that we're currently in stat plot because it's highlighted. It's currently turned off because off is highlighted. On is flashing because that's where my current cursor is, right? How do I turn it on? Press enter. It's now turned on. This is a scatter plot. My X data is an L1. My Y data is an L2. I'm going to plot each point with a little bitty square. If you want to change it to a plus or a big dot, that's cool. Never change it to a small dot. If you want to change the color, you can do that too, but I don't care. We're not messing with that. Okay. So the settings are like I want to see them. Now, what happens if you press graph? Do you see the data?
There's dots.
Okay. Does that look like they're in line? They might be, might not be. Okay, here's the problem. Those 4 or 6 points are so close together, actually, you can't even see a couple of them because they're up here, right? 11 and 29 are greater than 10. So you only see 4 out of the 6 points. If I want to see all of my data, I can use the zoom feature of the calculator. Do you see the zoom button? Press zoom. What are we currently working with? Look on the screen. I think I heard someone say it. What are we working with right now? Stats. Right? We're working with stats right now. So zoom stat, what zoom stat will do, it will make the window in such a way that every point that you put in the calculator will be on the screen. So let's go ahead and zoom, go to number 9. Now let me ask you the question again. Does all of our data appear to be in a straight line?
No.
We all see a nice curve there, don't we? Okay. So back on our notes over here, it said, if the points when well, not yet. One method of determining how X and Y values on a set of nonlinear data, is this nonlinear data? Okay. Is to take the natural log of every X value, and we're going to take the natural log of every Y value. Folks, that's a lot of math. I have 6 data points. That's 6 Ys and 6 X's. That's 12 computations of natural log. I'm about to show you how to use the calculator to do this for you. Okay, huh? Computation. Well, if I wanted to compute 2 times 3, I would say that's 6. Okay. Okay, go back to stat. Go back to edit. All right. In the past, we've always entered a piece of data 1 piece at a time. Okay, I'm about to do something totally different with you. You saw it the other day. Okay, I'm going to arrow over and I'm going to arrow up. I'm currently on the header for column L3. I want the values in column L3 to be the natural log of my X's. My X's are in L. Okay, so now that I'm up here, right in the bottom left of your calculator, it says L3. L3 equals, okay, L3 is going to equal natural log. Natural log of what?
L1.
L1. How do you type L1?
Second one.
Second one. Close my parentheses. So again, L3, list 3 is going to equal the natural log of list 1. Press enter. I don't care. Okay, so these values are all natural log of X. I want to put natural log of Y in 4. So to do that, arrow over, go up to the L4 header. I want column L4 to equal natural log of what? L2, second 2, close parentheses, enter. Is that kind of a neat way to do a lot of math in a couple steps? Okay. Now, go back to stat. Let's do another calculation. That's not right. Where am I supposed to be? You're right. Go back to stat plot. Sorry. Moment of cranial flatulence. No, that's much more sophisticated than the other. Okay. Where is my X data now?
List 3.
List 3 was natural log of X, right? So change your X list to L3. So I'm down on L1 right now. Second, 3, I just changed it to L3. My new Y data is in second, 4, enter. I want to see my data. I want to see all of it. How do I do that? Zoom stat, zoom 9. Now, there's my new graph. Does that appear to be linear? Yes. Okay. Do y'all remember ever working with the correlation coefficient to see how strong a set of data fits to a line? The closer to 1 or -1. A 1 is a perfect match with a positive correlation. A -1 is a perfect match with a negative correlation. Okay. This data is going to be positive correlation because it appears to be going up. Is it 1? 1 would mean that every single point lies on the exact same line. Okay, to compute the correlation coefficient, we have to turn the diagnostics on the calculator. By default, anytime you reset your calculator, the diagnostics will be off. So to turn diagnostics on, let's go to mode. And do you see anything on there that has to do with maybe statistics and diagnostics? Okay, I'm going to arrow up to get to it, I think. Yes, I'm going to arrow up to stat diagnostics. It's currently off. I'm going to go over, press enter, and turn it on. How are y'all doing today? Y'all staying with me okay? Okay. All right, now that diagnostics is on, I want to do a linear regression. Do y'all remember doing that? Finding a line of best fit, right?
Yes.
Okay, so to find a line of best fit, go to stat. Go to calc. Which one is linear regression? Which one makes a line? Number 4. Okay, now, where is my X data? L3. Second, 3, enter. Where is my Y data? Second, 4, enter. Let's go ahead and store it into Y1. How do I do that? Alpha, trace, number 1. Oh, not there. Go down to store equation. Now, alpha, trace, Y1, next to zoom, up at the top. By storing it, we'll be able to see not only our points, but we'll also be able to see the line. Instead of having to type the equation in, it's going to store it for us. Okay. Okay, go press enter. Press enter on calculate. What is the slope of the line that appears to go through those points?
1.4.
Okay, 1.49, about 1.5. Y'all good with that? What is the y-intercept? Where does it cross the y-axis? Try again.
8.21 times 10 to the negative fifth power.
Which means 0.00008. Okay, that's pretty small, right? Point, because you got to move the decimal over to the left 5 spots. So How much is 0.00008?
Basically 0.
Perfect. So we're basically going to ignore it. So the equation of this line is going to, we'll talk about the equation of the line in a second. Is it a strong fit? Is that pretty close to 1? Man, this is super strong. Press your graph. Does the line pretty much go through all the points? Pretty much. Pretty much. Looks like it's a little bit off on this one here more than anything, right? But it pretty much goes through all the points almost perfectly. Okay. So I'm going to press the y equals. So it stored all those nasty numbers in there for us, okay? So if I was doing regular statistics, if I was only using x's and y's, like these numbers here, the 0.387 and 0.241, I would say that that equation is y equals 3/2 x, right? But let me ask you this. Is our data x's and y's? Represent? Natural log. Column 4 represent? Natural log of y. That's why the formula is going to look like natural log of y equals m natural log of x instead of y equals mx. Can you see how those are pretty much the same? Okay, so we're not going to do that. Okay.
Wait, I have
I don't know what that's all about. Okay, so I've talked a lot, and the question, someone said, what is the question even asked? We'll get there in the next slide. Okay, but what have I shown you? I have shown you that I've got some data that's not linear. If I take the natural log of all the x values and the natural log of all the y values, my data is now linear. Y'all good with that? Yeah. Okay, next slide. It's over there. I don't know if that thing's ever going to go away or not. Okay, so here is what the graph looks like. That's kind of what we had on our screen. So that's the plots given by the above table. It's clear to see that x does relate to y, but it's not linear. Next slide. Taking the natural log of all the x values and all the y values, there's your table of results. We've got those in our L3 and L4. Next slide. What is this all about? Go away. Okay, thank you. I clicked on it and nothing, and I said go away, and it disappeared. Okay, here is the data plotted after taking natural logs. We looked at the slope, and it was pretty close to 1.5, right? So that gives us this. Now we're going to write the equation of the line. What is the equation of that line? It's already written right here for you. The equation of that line is natural log of y equals 3/2 natural log of x. By the point slope form, the equation of the line is y equals 3/2 x, where y equals natural log of y and x equals natural log of x. Therefore, again, natural log of y equals 3/2 natural log of x, and that is it. Okay, so we came up with an equation that could be used to represent the distance from the sun that each of the first 6 planets are. Yay. So you're excited to get to work on your homework. Excellent.